Okay, geometry, let's pick up with the second half of our 12.5 notes. So yesterday we reviewed the general equation for the equation of a circle right here and said how it was somehow related to the Pythagorean theorem, and then did a whole bunch with that in terms of starting with the equation of a circle and then trying to graph from that. Today what we're going to work on is kind of going in the opposite direction. We're going to work on writing the equation of a circle, which is something you did a little bit of with lines back in Algebra 1 last year, and it's something you're going to do a lot of next year in Algebra 2 as well, where they give you certain information and ask you to come up with an equation. So if we're trying to write the equation of a circle, it's probably helpful then to remember that the general form or standard form for equation of a circle was x minus h quantity squared plus a y minus k quantity squared was equal to r squared. So, in this problem, they've told us what the center of the circle is, and they've told us the radius. And if you remember that the center, everybody, is given by the ordered pair of h, comma, k, then we've already got all of the information that we need in this problem. This x-coordinate of the center here is our h value, the y-coordinate of the center here is our k value, and the radius is given to us right there. So in this particular type of problem, this is going to be a pretty quick and easy one right here. We're simply going to take x and subtract the x-coordinate of that center right there. So this is going to be an x minus 7, close the parenthesis, and quantity squared, plus we've got a y, and then minus our y-coordinate right here. So because that's a minus negative 3, this is actually going to be a plus 3 quantity squared equals, and this is a spot where people make mistakes all the time. What goes on the right side of the equation is the radius squared, not just r, but r squared. So since r is equal to 11, we need to square that number, and we'll go ahead and simplify that and make that a 121 that goes over here on the right-hand side. So that's the answer to this problem. That one is done. It was pretty quick and easy because they more or less gave us everything that we needed. But just a couple of things to point out there before we move on. If you take a look at the center, the x-coordinate was a positive 7, but right here in the equation, it looks like a negative 7. That's because the equation is actually subtracting the value of h. And right here, our y-coordinate is a negative 3, but over here in the equation, it looks like a plus 3. Because we're actually subtracting that negative 3. And the last thing, the radius was 11, but this number here is the square of the radius. So we make that a 121, and we don't just put an 11 there. All right, let's move on to the next one here. Okay, it gets a little bit more complicated now. They don't always give you the center and the radius. In this case, they've given you the center of the circle, and they've also told you a point that is on the circle itself, or a point that the circle passes through. So in trying to identify what we know, these values for the center here are h and k, just like they were before. But when they've given you the coordinates of that point right there, let's go all the way back to our first slide from yesterday's section and realize then that x and y represent any point that are located on the circle. So with that in mind, these values become a temporary x value and a temporary y value. That was actually a negative 3 right there. So, putting that in the context of the equation of a circle, which was x minus h quantity squared plus a y minus k quantity squared was equal to r squared, what we see here is an equation with 5 variables. And in terms of what was given to us, we know the values of h and k and a temporary value of x and y. The only thing that's missing is r. But that's the key there. In any equation, we can deal with one unknown. We can't deal with two. So now let's start filling in what we know here. Underneath this, the x-coordinate of the point that we were given is right here, and our x-coordinate is 1. So we start with that. We're going to subtract our h-coordinate, which is right here. But because h is negative 4, we're subtracting a negative 4, which is just going to turn that into a plus 4. Close that parenthesis and square it. Plus, and here we go in parentheses now, our y value right here was a negative 3. And then we're going to subtract our k value, which is located right here, and that's going to be a 9. We'll close that set of parentheses, square that, and again, we don't know the value of r right now, so we'll just leave that as it is. Okay, trying to save some space right here, I think we can do two things at once. 1 plus 4 is going to get us a 5, and then we're going to square that 5 to get a 25 right there. The negative 3 minus 9 is a negative 12. We're going to square that. I would really hope you guys don't need your calculator to square a negative 12, but if you do, remember that it's essential that you put parentheses around that negative. If you just type in minus 12 squared in your calculator, you're going to get negative 144, which is not what we want. But when you put parentheses around the negative, you're telling the calculator to treat the base as a negative and then square that. That's going to be a positive 144 is equal to r squared. Combine those two like terms and we're going to get 169 is equal to r squared. And then we'll take the square root of both sides of that equation and get r equals 13. Actually, we probably could have stopped right there. Once we knew what r squared was, the actual value of r doesn't really matter, because now at this point, let me do some highlighting in a different color here. Now at this point, we actually know the three things that we need to know to write the equation of a circle. We've got an h value right here of negative 4, we've got a k value right here of 9, and we know the value of r squared. So when we go back and we think about this equation right here, everybody, which is what we need to write here for the final equation of a circle, the three things that we really needed to know are h, which we have, k, which we have, and the value of r squared, which we have. So all the work is done, we just need to finish this up. So back to standard form here. It's going to be x minus your h coordinate here, so that's an x plus 4. Close the parenthesis and square it. Plus, we have a y minus our k value right now, so that's a minus 9, close it and square it, equals, and now we're looking right here at r squared, and we know right here that the value of r squared is 169. And that is the equation of the one and only circle that has its center at negative 4, 9 and passes through the point 1, negative 3. And one last example that we're going to do here is similar to B, but a little bit more complicated. What they did here is they gave us the endpoints of the diameter. Now, at first glance, it might not seem like that helps us all that much. The two things we need to know about a circle are its center and its radius, and neither of those were given to us. But if we do a little playing around with this, we can see here pretty quickly that in a circle, if they've given you the endpoints of one of your diameters, like for example, this and this. All right, so if they gave you the coordinates of point A right here and point B right here, the question we have to ask ourselves is, how could we figure out the center if we know the endpoints of a diameter? And the answer to that, hopefully you saw it, is that the center of your circle is going to be the midpoint of your diameter right over there. So if we remember our midpoint formula from way back in chapter 1, we're going to be able to figure out that center without a whole lot of difficulty. So the formula for midpoint, which you may have forgotten, but you might have it in your notes, and you could always Google something like this, guys, would be to take your x1 coordinate, add it to your x2 coordinate, and then divide all that by 2. Now remember, when you're adding two numbers together and then dividing their sum by 2, you are finding the average of those two numbers, and that's exactly what a midpoint is. Now this right here just gives you the x-coordinate of the midpoint, comma, and then we have to do the exact same thing again with the y-coordinate of your midpoint. So y1 plus y2 all over 2. Okay, so with that in mind, our midpoint here, everybody, our first x-coordinate is a negative 2, our second x-coordinate is a negative 8. So rather than writing plus negative 8, you guys aren't in middle school anymore, we know that that's just going to be a minus 8. And then all divided by 2, comma. And then here we go, adding our y-coordinates together. The first y-coordinate is negative 5. We add that to the second y-coordinate, which is 3, and we divide all that by 2 as well. So, a little bit of simplification, and again, I think you guys can handle doing two things at once in your head here. We are going to take the negative 2 plus 8 right there to get a negative 10, and then divide that negative 10 by 2 to get negative 5 for the x-coordinate of our midpoint. And for the y-coordinate, this negative 5 plus 3 is going to get us a negative 2 divided by 2. That's going to equal a negative 1. So right there, we've just located our midpoint. And as we said, the midpoint of a diameter, everybody, is going to be the center of our circle. That tells us now that h is equal to negative 5 and that k is equal to 1. So that's two of the things that we needed to find right here. From this point moving forward, this becomes a lot like the problem that we just finished in example B, where we know the center now and we know one of the 2 points on the circle. The one thing you want to do before you go any further here, and we did this with equations of lines way back in chapter 3, decide which of these 2 points on the circle you want to use, and then just cross the other one out. So I'm going to use this second point right here because it at least has one positive number in there, and I'm not going to use the negative 2, negative 5, at least not for now. So where we are right now is we know our center, so we know the values of h and k, and then with these 2 points right over here, that negative 8 is going to be our x-coordinate, and that 3 is going to be our y-coordinate. All right, so with those 2 things in mind, let's go ahead and let's try to write out the equation of a circle in standard form. All right, so the general equation, and until we know it, we better write this as much as we can, x minus h quantity squared plus a y minus k quantity squared is equal to an r squared. And just like in the last example, we don't know the value of r, so we fill in everything else. Our x value is a negative 8, and then minus h. Well, h right here was negative 5, and minus negative 5 is going to make a plus 5. Close it, square it. Plus, and now on the second part, our y value right over here is 3, minus our k value of negative 1, so that'll actually become a plus 1. Close it and square it, and all of that is equal to r squared. Okay, trying to save room here. Negative 8 plus 5 is a negative 3. Squared is going to get us a 9. 3 plus 1 is 4. Squared is going to get us a 16. So 9 plus 16 is equal to r squared. And r squared is equal to 25. Now I realize now when I wrote these 2 problems, I did them, you're welcome, in such a way so that the radius would work out to be a whole number. But that actually isn't relevant at all because we really don't need the value of r for the equation. We need the value of r squared. So what we really need to tie all this together, and we're pretty much there here, everybody, is this value of r squared, and then these values right here of h and k. So, knowing those 3 values, we're ready to go ahead and write our final equation. And of course, I'm out of room, so we're going to go to the next page in order to do that. Okay, so the x minus h, everybody, is going to be an x, and since h was a negative 5, that minus negative 5 actually looks like a plus. So x plus 5 squared plus, and then we're going to go with a y minus our k value. K was negative 1 right here, so the minus negative 1 is now going to become a plus 1, close it and square it, equals, and the value of r squared we came up with on the last slide there was 25. And that is the answer to this last problem here. Now the one thing I do want to do is just to take a minute and use that one-ordered pair right there that we didn't use. That's a point that's located on the circle. Negative 2, negative 5. So when we use that point as a point on the circle and plug that negative 2 in for x and this negative 5 in for y, we should end up with a true statement. Let's check it. Plugging the negative 2 in there, negative 2 plus 5 is going to get us a 3, and that 3 squared is going to be a 9. Plus, we've got a negative 5 that goes right here, plus 1. Negative 5 plus 1 is negative 4. Squaring the negative 4 is going to be a 16. And that is supposed to equal our value of r squared. And sure enough, the 9 plus the 16 right there is going to get us 25 equals 25. And that one checks out. Okay, that's a wrap on section 12.5, everybody.